I am Neeta Sharma from PM Expert. Today we'll learn how ensemble methods in machine learning make models stronger with simple explanations and real-world examples. Imagine asking a group of experts instead of one person. Ensembles do exactly that for models. When you combine different opinions, the mistakes tend to cancel out, and the decision gets more reliable. So what is an ensemble? We train multiple models, often called base learners, and combine their predictions into a single final output. Many weak opinions can form a strong decision when they are diverse. For regression, we simply average the predictions. For classification, we take a majority vote. Here are the short formulas on screen. Why do ensembles work? First, averaging reduces variance. Random ups and downs in different models cancel out. Second, when models learn different patterns, their errors are different. Combining them can move us closer to the truth. Watch how the average lands nearer to the true value line. First, bagging, short for bootstrap aggregating. We draw many random samples with replacement from the dataset, train the same type of model on each sample, and then average or vote their predictions. This lowers variance. A popular example is random forest, which builds many decision trees and combines them. Next, boosting. We train models in sequence. Each new learner focuses more on the examples the previous learners missed. Then we combine them with weights. This often reduces bias and gives top accuracy on tabular data. Famous libraries are AdaBoost and gradient boosting methods like XGBoost, LightGBM, and CatBoost. Finally, stacking, also called stack generalization. We train different kinds of base models, collect their predictions, and then train a meta-learner on top of those predictions. This captures complementary strengths across models. Real-world use cases: fraud detection in banking, recommendation systems, medical risk prediction, and weather or demand forecasting. Ensembles help by increasing robustness and accuracy across scenarios. Practical tips: use random forests when you want robustness with minimal tuning. Use boosting methods like XGBoost, LightGBM, or CatBoost for top accuracy on tabular data, but watch for overfitting and tune learning rate and tree depth. Use stacking when models are complementary and you have enough data. Always validate with cross-validation and monitor bias versus variance. Ensembles can be harder to explain, so consider feature importance and SHAP tools. A short pseudocode view of stacking. Train base models on a training set, collect out-of-fold predictions, then train a meta-model on those predictions. That was a quick tour of bagging, boosting, and stacking, and when to use them. I am Neeta Sharma from PM Expert. If you want a downloadable cheat sheet or Python code examples, tell me which one you prefer. Final recap: many models combined wisely yield stronger predictions.